questions. So today we are going to cover the TCP, the basics of TCP. Okay, basics of TCP. Now, TCP is the favorite question of most of the interviewers. Okay, if you appear for Google or Amazon or Cisco, there will be question on the TCP packet. So you need to understand how the TCP packet looks like. So, but before you understand how the TCP packet looks like, you should understand what are the functions of the TCP. Only if you understand the functions of the TCP, you will be able to reconstruct the packet, the TCP packet. Okay. So first question is, at what layer the TCP works? At what layer TCP works? It is layer 4. If you remember the OSI layer, it's TCP and UDP works at layer 4. Then what is the data unit called at TCP layer? It's called as segments, isn't it? Okay. Now, is TCP connection oriented protocol, or is it reliable, or a reliable protocol? Yes, it is. Now, why do we call TCP as a reliable protocol? When do you say a communication is reliable? Whenever you say hello to a person, that person when responds back to you with a hello or how are you consider that communication as a reliable communication, because you know that what you are saying is reaching to that person and that person is able to respond back to you. So that is a reliable communication, right? So whenever TCP sends any packet, it expects an acknowledgement. Okay, so that's why TCP is connection oriented or reliable. So what are the fields that takes care of this reliability? Basically, it's a SYN packet and the acknowledgement packet. Any data that TCP send to the destination, it will send a SYN packet and the sequence number of the SYN packet. SYN, the full form is synchronization packet, and a SYN sequence number. And TCP expects an acknowledgement to that SYN packet. Okay, so that ACK packet will have an acknowledgement sequence number. Hence, there are two fields which are very important in TCP. That is a SYN packet sequence number and an acknowledgement packet sequence number. You got it? Okay. Now we got each of these fields are 16-bit field. Now you know the two fields based on the function of the TCP. Now next, how does the TCP or how a machine comes to know what application is hosted, correct? Or how an application is hosted on a particular server? It is based on the port number. Okay, if you are hosting a web server, then you will be hosting it on a particular port number, maybe 80 or maybe 8080, correct? So that port number is very important. Whenever a communication between two machines happens, okay, the TCP port number is associated with that communication. So for every TCP connection, we need a TCP source port and destination port. So TCP source port. Now we have two fields, source port and destination port, and each of 16 bits. So we got another two fields, right? Now here a question. Will the destination or the source port can change during communication? If a server is hosting a particular service, for example a web service, it will be hosting that web service on port number 80 or 8080. Okay, the engineer or the architect who is developing that web application will decide on what port number he wants to host that service. So that port number of that service will never change. Okay, so whenever a user wants to connect, for example, www.example.com, so he will have to connect it on www.example.com colon 8080. How does let me write it down. Example.com colon 8080. Okay, this is what you call as URL. Okay, it has a port number 8080 along with www.example.com. Many a times you may not need to exclusively write the port number. It is automatically understood that if suppose if you write www.example.com, it is implicitly understood that the site is hosted on port number 80. Okay, so it can be HTTP or it can be HTTPS. So HTTP works on port number 80 and HTTPS works on port number 443. This is a secure HTTP. Okay, again I'll go into the depth of secure HTTP. Also it is a part of security. So as of now let's park it okay for the next session. So the port number 80 and the port number 443 are the ports on which you are hosting your web service. So when a user is trying to connect example.com, the destination port will always remain 80 or 443. Okay, it will never change. And when the server responds to the user, the server will respond to the user port, to the source port, so the destination port of the server will become the user port and the source port will be 80 and 443. Okay, and when user tries to connect example.com, he will open his connection. Okay, the user will open his connection on any, it's not a fixed port, it can be any port. Okay, and that port will remain common till that session is there. Once that session is broken, and again if the user starts another session, that source port may change, but the destination port number 80 will remain constant. Okay, so the user port may change with every session. Not may, it will change with every session. And that's why the user port is called ephemeral port. Okay, because ephemeral port means something that changes, it's not constant. So now you got it, that you need a source, you need a information of source port and the destination port, each of 16 bit. Okay, now what? TCP has a function of flow control as well. What are the other functions of TCP? Flow control and error recovery. So how does the flow control happens? Through window sizing. Whenever a communication has to happen between the two computers or between the two machines, they should decide how much data receiver can accept and how much data transmitter can send. Okay, so they come to a conclusion and then a window size is decided. and this window size keeps on changing, okay, depending upon the recipient capacity of accepting the data at one time. So this is called as window sizing. So by changing the window size, TCP does the flow control, how much data to be sent in one session. Okay, this is called flow control. And error recovery, as I said, error recovery means for any data, it requires an acknowledgement. Okay, for any SYN that is sent, it requires an acknowledgement. And if the acknowledgement is not received, that means an error has happened, and again the TCP will send the SYN packet. TCP will keep waiting for that acknowledgement. Okay. Next, what are the other functions of TCP? TCP also maintains the session, okay, initiates the session, maintains the session, and tears down the session. And how does it do? How does it do? How does the TCP maintains that session? By initiating three-way handshake. First, a SYN packet will be sent, and as I told you, the SYN requires an acknowledgement. So the receiver will send a SYN and ACK. Okay, and then to this ACK, the source will again send an acknowledgement. So this completes the three-way handshake. Now the two machines are ready to share the data. Correct. So first is the three-way handshake between the sender and the receiver. That is the first thing that has to happen. Whenever TCP initiates a session, first thing that will happen is a three-way handshake. Sender will send a SYN packet, receiver will acknowledge that SYN packet, okay, and to this acknowledgement again sender will send an acknowledgement. So it completes the, it's like you say a hello, and then the other guy will also say hello, how are you, and then you will say I am fine, how are you. So it's like now you are ready to talk, okay, or send a data. Then it will maintain the session. How does it maintain the session? Using flow control, again using SYN and acknowledgement, and then it tears down the session. So how does it tears down the session? It tears down the session by using a graceful finish, a FIN packet, or an abrupt reset packet. Correct? And okay. So TCP requires two more, what do you call? Okay, let me just. So TCP requires 6 flags. What are those 6 flags? As I told you, SYN requires a sequence number, and acknowledgement also requires a sequence number. But how does the machine will come to know if the packet that is coming is a SYN packet or acknowledgement packet? So there is a SYN flag. If the flag is set, that means the coming packet is a SYN packet and it will carry the SYN sequence number. Okay, so this is one flag. Again, if the received packet is an acknowledgement packet, then the acknowledgement field will be set and it will carry the acknowledgement sequence number. So this is the second field. Third field is finish. Just to initiate a session between TCP, it requires SYN, SYN-ACK and SYN write. So for graceful finish also, it requires finish packet, acknowledgement packet, and finish packet. Like it is a 4-way handshake. So finish packet, next comes SYN, acknowledgement and reset packet. For example, if you are watching a news website, for example timesofindia.com, and a after you are done, you will simply close the browser, right? So what it is? It is an abrupt termination of the session. So the TCP will send a reset flag, a reset packet, to indicate that the session is terminated. So that is the reset. Now there are two more, push and urgent flags. So push flag, normally you will see when a data is sent to the receiver. So when it's the last packet, so receiver don't have to wait. How does the receiver come to know that this is the last packet of the communication? It is to the push flag. Okay, so it doesn't have to wait for another data to buffer. It will simply the last packet will have the push flag set, so it will simply send this packet to the upper stack. Okay. And next is urgent pointer. Urgent is used in a very typical situation where a certain data needs to be processed urgently. So if this flag is set with that data packet, then immediately that packet will be processed. So these are the 6 fields which you need to remember in a TCP field. Okay. Next comes window size. As I told you, the TCP has a window size field. Okay, for full flow control, it is of 16-bit. Then your TCP header length, it will be of 4-bit, and TCP checksum, and this is of 16-bit. What is a checksum? Checksum is like to verify if the received data is error free or it is not tampered during the transit. So whatever checksum is calculated by the sender will be recalculated again at the receiver end. If it matches, that means the received data is free from error and it is not tampered during the transit. Okay, and it is accepted by the recipient, and it will not ask for the retransmission. So whenever you see a retransmission, that means something is wrong. Something wrong is happening with the TCP packet during the transit. Okay. So there is another field. It is a TCP reserved field. Reserved field is used. It is reserved for future use. Suppose if they want to add any new features to the TCP packet, then this field can be used. So it is of 6 bits. Okay, all these flags are of 1 bit. Okay. And that's it. So now we know what are the fields of the TCP packet. One is acknowledgement and SYN sequence number field, each of 16-bit. Why we need them? For error recovery. Correct? Because TCP is a connection oriented protocol, because it's a reliable protocol. For reliability, you need a SYN and acknowledgement and its sequence number. Again, for flow control, we need window size, right? So there is one more field. We need a TCP source and destination port, correct? So there is 2 fields, source port and 4th is destination port. Now there are 6 flags, right? To understand what type of packet is coming, correct? Those are SYN, acknowledgement packet, finish packet, reset, push and urgent. Push and urgent basically tells the recipient machine how to deal with the received packet. Then the 6th is TCP reserved field. It is of 6 bits. Then you have a TCP checksum, TCP header length, TCP header length, and TCP checksum. So these are the 8 fields that needs to be That you should remember when you for a TCP, when you appear for the interview. Okay, and how do you remember? You remember by understanding the functionality of the TCP. Okay, so what are the functionality of the TCP? TCP is a connection-oriented protocol, requires acknowledgement for all the data sent. Again, TCP requires a source port and a destination port. TCP requires there are 6 flags of SYN acknowledgement, finish, reset, push, and urgent. Then TCP header length and TCP checksum is anyways needed. Then you have a TCP reserved field. And finally, for flow control, you need a window size. Okay. So finally, how the TCP packet looks like? Let me just share it on the screen. It looks like this. So TCP packet can be of 20 bytes or maximum 160 bytes. Okay, that's it for today. So tomorrow we will understand, in the next session we will understand what is MSS, what is MTU, okay, and how the firewalls, what are the questions related to stateful firewalls that can be asked in the interview, and it is related to TCP. Okay, what is stateful, what is stateless. Okay, thank you, bye.